Good morning, Abhishek.
Good morning, sir.
Today we are going to see control system basics and a problem based on the basics of control system. Okay.
Okay, sir.
So, do you have any idea about control system? Presently, which semester you are? Abhishek.
Sir,
Which semester?
sir, voice
Yeah, which semester you are studying?
fifth semester.
Sixth semester.
Fifth semester, sir.
Fifth sem. Okay, okay. You are studying
Study,
control
sir.
system, right? Already.
Yes, sir.
Okay. So in this subject, we are going to see basics of control system components, feedback principle, transfer function, block diagram representation, signal flow graph, transient and steady state analysis of a linear time invariant system. Okay, frequency response, stability, Routh-Hurwitz, that is a stability criterion, Routh-Hurwitz and Nyquist stability criteria, Bode and root locus plots, lag and lead compensation, state variable model, and a solution of state equation of linear time invariant system. Okay, so these are the topics present in the GATE 2021 in ECE syllabus. One other that is in GATE 2021. Many subject is there in which control system the following topics only is there. Okay, is it clear?
Okay, sir. Okay, sir.
Abhishek, whether it's in the for you it's a meeting is recorded, it's showing like that or not?
Yes, sir. Showing, sir.
Okay,
Yes,
good.
recording, sir.
Now in syllabus it's clear, right?
Yes, sir.
Okay, let's be before solving the problem. Just we will consider. I am going to divide this syllabus into eight units. Okay. So
Okay,
first
sir.
unit we are going to see uh, basics of control system components. Okay, we are going to see the basics of control system component, feedback principle, transfer function. Okay, so this talk
Okay,
on block diagram representation, signal flow graph. Till signal flow graph we are going to see today. Okay, first we will discuss
okay,
some
sir.
key points before solving the problem. Okay, since you have studied in a long time back this subject,
That's
some key points you should know. So just I'm revising. Already you know that. Just for recollecting those points only, I'm doing that. Okay. After that, we will go for
okay,
the
sir.
problem. Fine. Okay.
Okay, sir. Okay, sir.
So now control system is nothing but you can divide the control system word into two terms, that is two words, control plus systems. Here first we will define a system. What is system? Do you have any idea about a system? If you know you can tell, otherwise I will tell, no problem, be casual.
System.
System means what?
A machine or something which provides output or input.
Yeah. So a system is nothing but it's a interconnection of various element in a logical sequence. Okay. A system is nothing but what? Interconnection of various elements or blocks connected in a logical sequence to get desired output. Okay. A system will have desired input and system will have the desired output. Is it clear? Abhishek, is it?
Yes, sir. Yes, sir.
So this
Yes,
here pictorial or a picture representation of a system. Here this is a system, control system. Okay, this is a system. So in a control system, output is controlled by varying the input. Why we are using the term here control means if the output is controlled by varying the input, or your outputs depend on here is what input. If your input is vary, your output is also vary, right? So that's why it's we are calling it a control system. Here the desired output can be controlled by input. Here the input is called as other name for the input command signal. Okay, other name for the input signal is command signal, and other name for the output signal is response. Okay, and this control system is called as plant. Okay, it's a plant. It's a plant. Is it clear?
Yes, sir.
Okay, fine. Now you understood what is a control system, right? Now, next. So example, let me see some example. Okay, the traffic light control and washing machine, ATM. So can you give some example for a control system? Real-time example.
Yes, sir.
Any example you can give. Today we are utilizing benefit of in all the field we are utilizing the benefit of control system.
Control system. Okay, sir. Sir.
Not only in engineering, not only in engineering field, in all the field.
Okay.
For example, if you take our environment ecosystem, in ecosystem, in food chain, if any one element get affected, what about the food chain get broken, right?
Yes, sir.
It will affect the entire system, right or not?
Yes, sir. Yes, sir.
So like that for not only this control system is applicable for the engineering only, it's also for various field, medical field, economics, like that. Okay. So here the real-time example, only few example here I mentioned here. The traffic light control, okay, washing machine, ATM. Okay. So based on, so it will be having the desired output. So based on the input will be setting, based on that it will process, you will be getting the desired. Okay. So these are the, sometimes you will, they may be asked the questions, give some example for the control system, like that they will mention some okay options. So you should think it and you should know that the real-time example of control system. Then classification of control system, another very important. Classification of control system. How we are classifying the control system? The control system classified based on the input. If the input is in analog form and output is in the analog form, then it's called as analog control system, right? If you are processing in form of your input is in the form of digital in nature, then it's called as digital control system. Here you see that continuous time and discrete time control system. One of the type is continuous time and discrete time control system. Control system can be classified as continuous time control system and discrete time control system based on the type of input used. So based on the input, we can classify the control system in the one way, continuous time and discrete time. In continuous time control system, all the signals are continuous in time. Okay, that is a sinusoidal way. Whereas in discrete control system, okay, so signals are in the discrete in nature. Okay, the amplitude only in the continuous, but the time period in the discrete in nature. Is it clear?
Okay, sir. Yes, sir.
And next one, next way of classification. This is one way of classification based on the input. Okay, and next way. SISO and MIMO control system. SISO, single input, single output, and multi-input, multi-output control system. So single output, single input and single output system means in the control system only one input is there, will be there, and only one output will be there. Such a control system is called as SISO system, single input, single output control system. And MIMO system example for okay, multiple input, multiple output control system. For example, a car you can give the same example for the driving a car is example for the multiple input, multiple output control systems, right?
Okay, sir.
Then, so these are the based on the input, okay, and next one based on the feedback we are using, whether the feedback are there or not. Based on that, also the control system classified into open loop control system and closed loop control system. Okay, so this control system already was aware of this open loop and closed loop based on the feedback is there or not. But
Yes, sir.
this
Like,
continuous time and discrete time and SISO and MIMO control systems are quite new for you. Okay, so this you should know. So SISO means single input, single output control system, and MIMO means multiple input, multiple output control system. Okay. So another way of classification is open loop and closed loop control system. So you know that based on the feedback, it will be classified. Okay. So here in the open loop control system, you see that the elements of open loop control system. Here you can see that a input is there, a controller or controlling element will be there. The controller will generate the actuating signal to the plant. It is a controlling signal will be given to the plant, so that the plant will generate the desired signal. Here you will be getting the output. Here you can see that the output, okay, whether we are here any feedback path is there?
no, sir.
No. So there is no feedback. Here whatever the input here, it will goes to the controller. The controller will generate the actuating signal. Actuating signal is nothing but controlling signal. Okay, and then it will go to the plant, and then here you will be getting the desired response. So how you can represent this system in terms of mathematics? Let's take the input is x of t. Okay, x of t, because it's a we are considering only in the time domain. Okay, then this is about the y of t. Okay, then here you can write y of t is equal to some transform, okay, transform or some operation of x of t. Here the x of t representing, okay, the x of t representing input signal, okay, the transfer function of the input signal, and the y of t is a transfer function of output. Okay, here you see that y of t equal to some operation. We are performing some operation, controlling operation. This controller only transforming operation. Okay, so this way we can relate the open loop control system like this. Is it clear? Is it clear?
Yes, sir.
Okay, fine. Thank you.
Yes, sir.
And next one, closed loop control system. So in the open loop control system, whether the input is there or based on the input, your output will vary. Okay, it also amplify the noises. Okay, and it will not be okay. It will not the whatever the effect present in the input due to error will not be automatically corrected. So for the automation, for automatic correction of the input based on the real-time scenario, we will go for closed loop control system. In closed loop control system, a part of output will be fed back to the input for the correction. Here, the the typical representation of the diagrammatic representation of closed loop control system. Here you can see that the elements of control system, element of closed loop control system. Here you see that input element will be there. Okay, and next to element, these block diagrams very important. When you are solving the gate problem, this whenever when you are they are saying that control system feedback they are telling this diagram you should remember. This is a very important for solving any type of CS problems. Okay, so input will be there, error detector will be there, or comparator, error detector or comparator, and controller. Okay, controller will generate the actuating signal. Okay, here you see that the difference of these two signal will be a error signal. Based on the error signal, the controller will increase the gain of the system or decrease the gain of the system, and then it will be applied on the plant. Okay, so that the plant will generate the desired response, and then we need to check whether the plant is getting the desired response or not. For that, a part of output fed back as a feedback element for the correction. For example, and this I can able to explain with a real-time scenario. Let us consider a room, the AC system. In a AC system, you can consider this one. Okay, suppose your present temperature of your room. Okay, present temperature of your room is 25. Let's consider. Okay, 25 degrees Celsius. And you are sitting in the okay AC temperature is 20. Let's take. Now what will happen in that in AC? What will happen?
Fed back to the input and
It will allow more coolant air right inside the room. Right or not?
yes, sir.
So once it reaches the 20, what will happen?
Stops.
It will stop and the temperature will be maintained as a
Maintain 20 degrees
Suppose
Celsius.
if you are opening the door or opening the window, it's are the noises. It are the
Yes, sir.
noises. So therefore, what will happen? The temperature again. It will what will happen?
Temperature
Rises, right?
decrease.
That is 22. Let's take it's a 22. Then again, what will happen?
AC
It will allow
temperature.
the cooling air so that the temperature will be maintained as long as 20
20
degrees.
degrees.
Right? This is a simple example. Okay, in a control system. Here,
Mm.
how this process will take place now? This will be processed in the okay in real time. I'm telling in the AC. Okay, controller will be there. MC microcontroller will be there. Microcontroller unit will be there. Okay, and this here a temperature sensor will be there. Okay, temperature sensor, PP sensor will be there, temperature sensor will be there, and this temperature sensor will sense the present temperature and comparing with the set point which you are setting by the set point, okay, by the remote or whatever maybe set point, and if it is equal, that is if it is 0 means there is no error. That means what? If the difference of error signal is 0, this indicates what?
No, 0.
When the error
No
will be
error.
0,
No
no
error.
error. That time only no error, right or not?
Yes, sir.
So no error means what? We'll be getting the desired result. Is it right?
Yes, sir.
Yeah. Okay. Good. Very good. Okay. So now you can able to understood that closed loop control system, right?
Yes, sir.
So elements you should remember: input will be there, error detector will be there, controller will be there, plant will be there, feedback element is
element.
there. Okay. So these are the elements of the control system. So you can ask, what is the use of controller, sir? Here, sometimes the control
Detect.
system may operate without the controller also. Okay, but we won't get desired response. What is that? The system may
Don't
be
get it.
stable. The control system may be stable, but we won't get desired response. புரியுதுங்களா?
Yes, sir.
To get desired response, we need a certain part. That part is nothing but controller. This controller may be a derivative controller, integral controller, that is P proportional controller, proportional integral controller, proportional derivative controller, or PID controller, proportional integral derivative controller. So this will be added so that we will be getting the desired response.
Desired response.
Yes. So the main function of the controller, this is very important gate question. That's why I'm telling. The controllers are used in a closed loop control system to bring unstable control system into stable. If it is the control system is unstable work aachuna, okay. If the system is already stable, the controllers are used to get desired response. Because of these two reasons only, we will be using the controller. Is it clear?
Yes, sir.
Okay, thank you. Next, we move on to the examples. That is the difference. You know that, right? Difference.
Yes, sir.
Okay, so the main difference here is here the feedback element in closed loop, the feedback element is there. In open loop, feedback element is not present. Okay, and the open loop is easy to design, whereas the closed loop closed loop control system difficult to design. Okay, and these are economical one because the number of components used in open loop control system is only, so economical one. Whereas in closed loop control system will be using more number of elements, so therefore it's a costly.
Costly.
Okay. Then here one more important point is the open loop control systems inaccurate. That means what? The output may be affected, the output and input may be affected by means of noise, external noise. It will not corrected automatically in open loop control system. Therefore it is inaccurate. Whereas in closed loop control system, okay, the disturbance signal taken into account by means of feedback. Okay, feedback element. So therefore the disturbance automatically removed to get the desired response. Therefore it's accurate. With respect to stability, okay, here the stability point is not here. With respect to stability, the open loop control system is more stable than the closed loop control system. The reason is, in a closed loop control system, okay, the linearity will not be there. The closed loop control systems will not be linear. புரியுதுங்களா? Is it clear?
Yes, sir.
So types of feedback, positive feedback and negative feedback. Okay, positive feedback means the input signal and feedback signal will be get added. Okay, here you see that actually this is a representation of a closed loop control system. R of S is nothing but input Laplace transform of inputs, and C of S is nothing but Laplace transform of output. G is nothing but plant transfer function. H is nothing but feedback transfer function. Is it clear?
Yes, sir.
Closed loop control system, that is positive feedback means the input signal and part of output signal will be in the same phase. That means it will be added. Okay. So where we'll be using the positive feedback in a control system? Whether we'll be using positive feedback? Actually, why we go for a positive feedback? Whenever we need automated, right? Whenever we need a desired response to meet out, for that time only we'll go for positive feedback. Sorry, for the control system. Whereas we are using the positive feedback now, what will happen now? Without any input, the system will generate the output. That means what? It behaves like a what? Oscillator. It behaves like a
oscillator.
Oscillator. It should behave like an oscillator. Okay, it's behave like an oscillator. So therefore, to avoid this one, we'll go for normally the control system will be employed with the negative feedback only always. Okay, will be employed with the negative feedback. So in the positive feedback now, the transfer function, you can see that here the transfer function t is equal to g divided by 1 minus g into h. The transfer function. Okay, the transfer function t is equal to g divided by 1 minus g into h. This is a transfer function of positive feedback. It's a very important formula. Okay. Here T is a transfer function, overall gain of the transfer function with the feedback. G is a loop gain with the frequency. Okay. And H is a feedback path, which is also a function of frequency. And next one is a negative feedback. So negative feedback here is the input signal and part of output signal 180 out of phase with respect to each other. Therefore, what will happen? These two signals will be get subtracted. So in positive feedback, sum of two signal will be get, but here you will be getting the difference of two input. Is it clear?
Yes, sir.
Okay. And next one, here you can ask the transfer function t is equal to g divided by 1 plus g into h. So positive feedback means plus will come, positive feedback means negative will come, negative feedback means positive will come. Okay,
Positive.
positive will come. We should not forget. Okay, this is a very important formula. This is for entire unit, and this formula will be using. Okay, is it clear?
Yes, sir.
Okay. The effect of feedback. So effect of feedback and overall gain. What will happen now? Only 2 points. Okay, only 2 points you should remember. So when you are using the negative feedback, what will happen now? Gain will be reduced. What will happen? Gain
Reduced.
Yes, gain reduced and bandwidth will be increased in negative feedback. I'm telling about negative feedback. Okay. Whereas in positive feedback,
Okay,
what
sir.
will happen now? Okay, gain will becomes infinite. The gain becomes infinite, and bandwidth becomes zero. Ideally, okay, that is narrow bandwidth, and gain will be infinite. Whereas in negative feedback, gain will be less, whereas the bandwidth will be more, okay, wider bandwidth. And next one important term is a sensitivity. And this term already you have studied in the electronic circuit 2 itself. Okay, the Barkhausen criterion. For the positive feedback, any system said to be satisfy the Barkhausen criterion, it becomes amplifier, oscillator, right? It becomes the oscillator, right? Or not? Can you able to remember
Yes, sir.
Barkhausen criterion?
Yes, sir. Gain
Yes.
AB greater than equal to 1.
The gain and feedback product equal to 1. That is modulus of A beta equal to 1. And the phase shift around any closed loop equal to 0 or 360 degree.
363. Yes, sir.
Right? Is it 0 or 360 degree? Is it right?
360 degree.
Okay.
Yes.
So here in that sensitivity is nothing but sensitivity is equal to rate of change of, that is percentage change of transfer function divided by percentage change of gain of the transfer function band. Here the dou is nothing but partial differentiation. Here the sensitivity, you can write sensitivity is equal to 1 plus G into H. Formula for the sensitivity, G by T is equal to 1 plus G into H. Effect of feedbacks on stability. A system said to be stable if its output is under control. Otherwise, it's said to be unstable. Okay. And these are the points.
Yes, sir.
Okay. These are the points. And next one, mathematical model of control system. So mathematical model means representing the control system in terms of a mathematical equation. Representing the control system elements in terms of block diagram or in terms of equations. Okay, it's nothing but mathematical representation. Here, first we should know that what is transfer function. Transfer function means what? Transfer function. Transfer function. Abhishek,
Yes, sir.
transfer function is equal to Laplace transform of output. Okay, Laplace transform of output divided by Laplace transform of input. Laplace transform of output divided by Laplace transform of input with zero initial condition. With zero initial condition. Is it clear?
Yes, sir.
Very important. With zero initial condition is very important. Zero initial condition. Okay, condition. So first, you can classify the control system. Another way is electrical control system, mechanical control system. Okay. So first we will see that electrical control system. What are the basic elements of electrical control system? Any idea? Basics of resistor, capacitor, inductor, right or not?
Inductor. Yes, sir.
Am I clear? Am I audible?
Yes, sir. Yes, sir.
Okay. So the basics of electrical control system is resistor, capacitor, and inductor. Okay. We'll be for finding the transfer function in electrical control system. We'll be using nodal equation and Kirchhoff voltage laws. Okay. Kirchhoff voltage laws and Kirchhoff current laws will be using for finding the transfer function of the electrical control system. Okay. For example, here you can see that if you apply the Kirchhoff voltage law for this equation, VI is equal to I into R of R plus L into di by dt plus the voltage across the capacitor is V naught. So here we know that the current through the capacitor is what? I is equal to C into dV naught by dt. Okay, so therefore we'll be getting VI is equal to RC into here. What I did, just I substituted in that wherever I is there, just I substituted I equal to C into dV naught by dt. So therefore here you will be getting L into C d square V naught by dt square. Here V naught will be there. Here dV naught by dt will be there. Then so this is second order differential equation, right or not? Second order differential equation. Is it right or not? Differential equation. Abhishek.
Yes.
So therefore d square V naught by
Yes, sir.
d square
Indeed.
R by L into dV naught by dt and 1 by L. So this actually in the mathematics subject you will be treating this as a, that is d by dt as a, we will be treating as a
Rho.
right or not?
Yes, sir.
Therefore this becomes what? How you can write?
D square V naught.
Yes, d square and R by L. Okay.
R by
D plus
1 by LC
1 by
V naught.
else, right? Like this you'll be
Yes.
getting. So in the mathematics. So it's a different, it's a second order differential equation. We need to solve this one. You can solve it by conventional way, particular integral, okay, pi, and that conventional way you can solve. In other way is by following the Laplace transform, you can easily solve this, okay, by finding the transfer function. So here in GATE exam, we need to save the time. So which method is following very easy now? You need to follow. That is Laplace transform method is very easy when compared to the conventional method. So okay, so you can follow that for solving the electrical control system problems. We may follow Laplace transform method. Okay. So next one, transfer function model. So just now I told, right, x of s is nothing but y of s. So therefore transfer function is equal to y of s by x of s with a zero initial condition. Is it clear? Just now we have discussed. Next one, now we will see that mechanical, that is mathematical modeling of mechanical systems. The mechanical system can be classified into two types of mechanical translational system, mechanical rotational system. Mechanical translation system, mechanical rotational system. In the mechanical translation system, what are the elements? Can you able to remember mechanical translation systems? Three elements only. Can you able to remember?
Yes, sir.
Yeah, what tell me? Mass,
Mass,
spring,
spring, torque,
dashpot.
Dashboard. Okay, sir.
Dashpot, right or not?
Yes, sir.
Dashpot. That is, mass means it will be represented like this, right? M, like M. Spring means it will be represented like this,
Yes, sir.
right? And dashpot
Yes,
will be
sir.
represented by, that is nothing but frictional representation. Dashpot is nothing but frictional. Okay, it will be like this. Piston. Is it clear?
Yes, yes, sir.
Okay, fine. So mass, you know that the kinetic energy of any mechanical system can be represented by the mass element, and the notation is M. Just now we have discussed kinetic energy and mass M. And here you should remember that here it's a displacement variable. This is x is a displacement variable and f is a force applied. So therefore, this is nothing but is a free body diagram. Free body diagram for the mechanical translational system. Okay, here you can write the force balance equation. Force F is equal to acceleration A. So for F is equal to m into A by Newton law, right? F is equal to m into A, where m is nothing but mass, A is nothing but acceleration. Is it right? Is it right?
Yes.
Yes.
Yes, sir.
So how you can write the acceleration? Acceleration is equal to
Sir?
this double differentiation of displacement is nothing but acceleration, right or not? So F is equal to m into d square x by dt square. Here, Fn, the force applied, opposing force applied by the mass element can be written as Fm, the opposing force offered by the mass element is equal to m into d square, displacement variable is here x by dt square. Is it clear?
Yes, sir.
Okay, like that for each element you should know for solving the problem. Okay, like that. Like that you can tell me the for spring you can tell me if you remember now easily. Then we'll go for next.
Yes, sir.
Fk is equal to,
Yeah. Yes.
you know now you can tell no problem. Fk is equal to k into x.
K.
K into x. right?
Yes, sir.
Here is a mass element, mass coefficient. K is a spring coefficient. Okay, and if it is a dashpot, what is that? FB is equal to, any idea?
D
Dx by
dx by dt.
good, very good. So that's all the equation. Here, the mass element is movable only one direction. If it is movable in the two direction, what will happen? The difference of two displacement variable you should write. Okay, very clear what I am telling?
Yes, sir.
If it is a mass element is moving in both direction, for this also, here also one more mass element is there. Okay, let's take is a M1. Okay, and here
Yes,
it's
sir.
M2,
M2.
and here is X1, and here it's X2. Then you can write the force balance equation for this. Fm is equal to, with respect to the mass element 1, you can write Fm1 is equal to, how you can write? How you can write? M1
M1
E square
D square x by
X1 minus
x2
X2 divided by
x2 divided by dt square.
here. Is it clear?
M2 into this. Yes, sir.
Next. And likewise for the spring, just now I told it's a Fk is equal to K into X. Okay, like that for the dashpot I told it's a B into dx by dt. Okay.
Yes, sir.
Likewise for the mechanical rotational system. Now it's a mechanical translation system we have discussed. So next one is a mechanical rotational system, in which the force will be a rotational force. Rotational force is nothing but
Theta.
torque. Just now you told, no, torque, rotational
Torque.
force.
Yes, sir.
And here for the mechanical rotational system also 3 elements will be there, basic 3 elements. In the place of mass, it will be a moment of inertia, that is J. J will be there, moment of inertia. The mass element is replaced by moment of inertia, and the spring element will be there, dashpot element will be there. The remaining elements will be the same. Am I clear?
Yes, yes, sir.
Here, this here, what do you call the moment of inertia, J. Okay, and here this here torque, applied torque. Then this is angular displacement. Previously, I have told it's a displacement, but here it's a angular displacement.
Angular displacement.
Okay, just now just wait.
D square theta divided by dt.
Hello, now it's audible.
Yes, sir.
Okay. So here this is a moment of inertia in the place of mass. Now it's replaced by moment of inertia J, and the applied force now it's called as a torque. The applied force now it will be called as a torque. And the next one is a displacement becomes angular displacement. It's a angular displacement. Previously it's represented by x, now it's represented by theta. Previously it's represented by force F, now it's replaced by T. Okay, is it clear? Now this will be a torque is equal to torque balance equation.
Yes,
T is equal to J into D square by
J into D square
dt square. That's all.
theta by
So remaining will be the same. For the same, likewise for the mass element, that is mass moment of inertia we have written. And likewise for the torsional spring, K into theta. Okay. Likewise for the dashpot. Okay. TB is equal to B into omega. Okay. So omega is nothing but actually a d theta by dt is called as a omega. Okay. So therefore it's a B into d theta by dt. So next one, electrical analogies of mechanical system. So next very important. So in this also you can expect the gate questions. Electrical equivalent of mechanical system. Electrical equivalent of mechanical or the analogous systems. Electrical analogies of mechanical system. Okay. So we can able to equate mechanical system and electrical system. Here it's a force voltage. Okay, we can equate the electrical system into a mechanical system in two ways. That is force voltage analogy and force current analogy. Do you remember this one? Force voltage analogy and force current analogy?
Sir.
Can you able to remember or not?
Yes, sir.
Yes, good.
Yes, sir.
Yes, good. So first we will see that force voltage, then we will go for force current. Okay, it's very simple. One simple rule is there. Okay, force voltage analogy, force voltage analogy. And here the mechanical system, let's take. So in mechanical system, what are the basic elements will be there? Basic elements, mass element is there,
Mass, dashpot, spring,
dashpot, and spring element is there,
spring.
right?
Yes, sir.
So the mass element is replaced by in force voltage, that is force voltage equivalent element is what? Inductor. L is represented by in electrical system is what? Inductor.
Inductor.
And the B is represented by R. R is what?
Resistor.
Resistor. Actually B is what? This B is what?
Dashpot.
Yes, the dashpot is equivalent to resistor in the electrical system. Okay.
Yes, sir.
And K.
1 by C.
1 by
C. Capacitor.
1 by C. Good. 1 by C. Capacitor. Right. So if it is a force current analogy, C becomes mass element becomes a capacitor, and here it becomes 1 by R. 1 by R.
1 by R.
Here.
1 by L.
Is it clear?
Yes, sir.
So this simple rule you should remember. That's all. This simple rule you should remember. Many times you will be asked, what is the electrical equivalent of mass in force voltage analogy? What is the mechanical equivalent of electrical system in force current analogy? Like that they will ask. Okay, is it clear?
Yes, sir.
Now for this one we can here written for this system they have written the equation. F is equal to, so the force balance equation here it's given, force balance equation F is equal to Fm plus Fb Fk, right? And what are the elements connected to the mass element? How many elements are connected? Dashpot is connected, spring is connected.
Dashpot, spring
And force, right? So the 3 elements are connected. All the threes are
Yes,
there or not, and the mass element itself, and the corresponding displacement is x. So therefore, we can write the force balance equation, that is F is equal to first m value, m into
m d square
d square x by
x by dt
dt square. Second
plus
one
b
plus b, very good, plus b
dx by dt
dx by dt.
dt
Very good, very good. Next
plus k into x
plus k
k into,
into
x.
x. Very good. Okay. So this one. Now this here, what we are going to do now, this we are going to use some approximation. Now force will be replaced by, okay, in the electrical system, what is the force we will be applying? Potential difference, right or not?
Yes, sir.
Then one more thing is there, d by dx by dt. This is a displacement. It's nothing but what? Velocity, right or not? In mechanical system, I'm telling.
Sir.
Velocity is nothing but what? Rate of change of displacement with respect to time is nothing but velocity, right?
Time.
With respect to time.
Yes, sir.
So we are going to apply this condition here.
Okay, sir.
We are applying this condition. So therefore, what will happen here? We'll be getting
F is equal to m into d square
that is d into v
v by dt plus b into v
into v plus. Here, if you need x and what will happen? Integration of
x integration of v
v of t into dt, right? Or not? V of
yes,
t will be getting into dt.
yes, sir.
So like that, v of t into integration of v of t into dt. Now you can replace. Now you can replace force by voltage v. Okay,
V, sir.
and m by L. That is in the force voltage only we are following. Force voltage analogy only we are following. Force
Okay,
voltage.
sir.
So you know, just now I told m is replaced
L
L, right or not?
L dv by dt, yes, sir.
B is replaced by
R
R. And here K is there missing. K is K. K is replaced by
1 by c
1 by C. And this this v is now is replaced by, actually v here is, here the v is actually is what? Velocity, right?
velocity, okay, sir.
In electrical system is equivalent to I, because force is here represented by voltage. Force is represented by voltage.
Voltage V.
Therefore, velocity will be becomes equivalent to what? Current only, right?
Okay, sir.
On that you replace now, you will be getting that electrical equivalent circuit for the mechanical system. Is it clear what I'm telling?
Yes, sir.
Here you see that what are the system. Just now I have drawn the diagram. Equation, now you can write the equation for this one. With this we will wind up. Okay. Here you can tell me the equation. What is the equation? Just now we are at B is equal to what I
V is equal to L
R in
L in
R
R into
dI dV by voltage across the
V.
resistor is what? Sorry.
That's R.
V is equal to R into I. Right or not?
R into I, yes sir,
R into I plus
plus
L into
L into
dV by
dI and dV by
dt
dt
plus
plus 1 by C
1 by C
integral I V I love
interval
V
V of t into dt, right?
dt. Okay sir.
So this only we have got the previous equation, right?
Okay sir.
So this here, the above equation, above diagram is equivalent to for electrical system of this one. Okay.
Yes sir.
So with that, we'll wind up. Continuation we'll see in the next class. Okay. Just now we will stay back.
Okay sir.
Abhishek, can you take the screenshot of that?
Attendance
By
what sir?
attendance I'm telling.
Okay sir.
Take attendance screenshot before leaving that. Take the screenshot.
Yes sir.
Just wait. I will screen share some other thing. Then you can just wait.
Okay sir.
Abhishek, you can take now screenshot. Are you taken?
Sir.
Are you taken?
Yes sir. Yes sir.
Okay. You can send it to Subramaniam sir. Are you having that his number?
Okay. Yes sir, having sir.
Otherwise, you can send it to me. Otherwise, I will send it to you. Okay. With that, I will start.
Okay sir.
Okay. Thank you.
Yes. Thank you sir.